some time I had wanted to try making a CPM computer. So when I needed an idea for my Coursera Embedded Linux project, I decided it would be a good opportunity to build a small prototype. The goal was to build a small concurrent CP M-86 computer using a Raspberry Pi Zero running Linux and a minimal 8086 emulator. Since I already had the Raspberry Pi Zero, I decided to use it for the project. I had not found a good use for it since I bought it, so it was a natural choice. For the display, at first I wanted to use some kind of electronic paper, but that would have meant choosing the right model, ordering it, and learning how to use it, and I was not sure I would have enough time. So instead, I used a display that I already had, a 3.5-inch KDE 6.2. For the keyboard, the choice was also easy. I had an old Zenith XT keyboard, and I thought it would be a good opportunity to learn about the keyboard protocol and how it works. So I decided to write a driver for it. I also ordered a pickle to test the driver on more than just one piece of hardware. For this project, I decided to use Linux because I find it very interesting and I thought it would help me learn more about it. For the build system, I chose Buildroot because it makes it easy to create a small customized Linux system. As for the init system, I wrote a small init script, which turned out to be enough for my purposes. It loads the required drivers, sets the console font and launches the emulator. In order to run CCP M-86, I needed an emulator. Since I wanted the project to be as small as possible, I needed to choose the smallest emulator I could find. For that, 8086 Tiny was the perfect choice. I also discovered that on my display the usual 80 columns and 25 rows were too small. So I adapted the emulator so that it could support a different number of rows and columns instead of using the hard-coded values. Now it has 60 columns and 20 rows. To do that, I removed the SDL part of the emulator, because otherwise I would have had to test everything twice, which was unnecessary for this project. The source code for CCP M-86 is available online, and I decided to use version 3.1, which is the latest version available. Some adaptations were also needed. For disk access, the 8086 Tiny emulator uses a BIOS call, whereas CCP M-86 uses FDC access. I also patched the hard-coded rows and columns so that they are read from the information available in the BIOS. Since I modified the width of the screen, I also needed to adapt the status line to fill the bottom line. Here is how it goes. As you can see, there is a command line that can execute some commands. As an example, let us write a program, a simple process descriptor viewer. The process descriptor is a structure that represents a process and lets us inspect some of its properties. Here we are interested in the currently running process, so we will use system call 156, which returns the process descriptor of the calling process. First, we display a welcome message. Then we print the name of the process, which is located at address 8H in the process descriptor. After that, we display the priority, which is the decimal value. Lower numbers are reserved for system processes, while user processes usually have a priority of 200 or above. We also display the current default disk of the process. Finally, we display its status, which tells us whether the process is running, waiting, or doing something else. Then we assemble it by running AS76 PDView and generate the executable with GenCMD PDView. Now we can run the program. The name is PDView, the priority is 200, the disk is A, and the status is run, which means the process is ready to run. That is the value a process gets when it is examining its own process descriptor. To leave CCP M-86, I use the HALT program, which I wrote so that the system can exit cleanly on different emulators. Even though this prototype is now working, that does not mean that the project is finished. For me it is still active and I would like to continue developing it. The system can already boot, accept commands and compile and run programs, so it already feels like a small complete computer. But there is still a lot that could be added. For example, I would like to implement setDef to configure the search path. implement gendev to generate disk parameter tables, add hard drive support for booting from the hard drive, and create an installer so that the system could be installed more easily, including on real hardware. And if the project keeps growing, it would also be very interesting to try adding the GEM desktop environment. So even though this project was created for a Coursera Embedded Linux course, I hope it will not stop here. I would like to keep improving it, and I hope it can inspire more experiments and more ideas in the future.